Now, without a doubt, anything you do in MotionBuilder is going to involve a scene. So let's talk about the objects that make up a scene. Your intuition would probably tell you that these are the objects that make up the scene. All of these things in the scene browser or in the viewer. And you'd be right. We've got a lot of different kinds of objects here. We've got models, we have lights and cameras and optical markers, which are types of models. And we've got constraints and characters and actors, which as it happens are types of constraints. And we have shaders and materials and textures, audio clips and videos and motion capture devices, and all manner of other things. And we call these things components. These are the core entities that make up a scene. If you're familiar with how Maya works, we might say that these are roughly equivalent to nodes. Like nodes in Maya, components interconnect to form a scene graph. And that's our scene, a graph of components. But there's another type of object that fits into this scene graph, and that's the property. Properties, like attributes in Maya, describe an individual component by holding some value of a particular type. So our scene graph has two types of connections between objects. First, there are source and destination connections. These are directional relationships, and they connect components to each other. Second, we have ownership connections. These are the one-to-many relationships between a component and its properties. Naturally, any given property must belong to some component. Properties can't exist on their own. All of these types of connections are implemented in FBplug, which is the base class for both components and properties. It's rare that you'd need to deal with connections directly when writing simple scripts, but if you want to examine an object's connections to feel your way around the scene, you can do so with these methods. Now let's take a look at this class hierarchy in a little more detail. FBplug is the base class for any object in the scene. As we've discussed, it implements this idea of connection, and its two subclasses are FBComponent and FBProperty. Given our basic knowledge of how the scene is assembled, we know that the scene graph itself is made up of components. Properties are part of the scene too, but they're not really relevant outside the scope of the component that owns them. All the actual objects that you're dealing with in a script, whether they're models or characters or marker sets or whatever, they're all going to be components. The interesting functionality that's unique to each type of object is obviously going to be found in the methods and properties of the corresponding subclass. But before getting into all that, it's worth figuring out what you can do with all of these objects by virtue of the fact that they're all components. In other words, what functionality does FBComponent implement? Well, there are three major features that are of interest to us right now. For one, components can be selected. Second, components have unique names. And finally, components manage properties. Let's see how we deal with each of these things in Python. Now we need a component to use as an example, and it could be any type of component, but let's make it a cube. And let's say that it's referenced by the Python variable cube. To figure out whether our cube is selected, we check the value of its selected property. If we want to select or deselect it, all we have to do is assign true or false to that same property. It's really that straightforward. Let's move on to names. Internally, there are three parts to a component's name, though only two of them are exposed to the user. You'll already be familiar with the plain old name, which is to the right of the colon, and the namespace to the left of the colon. Both of these together give you the long name, or label name. The hidden third part of a name is called the group name, and it's joined to the long name with a double colon to give you the full name. The group name can't be changed, and it's simply determined by the type of object you're dealing with. To access or change just the name, or you might call it the short name, you use the name property. For the long name, you'll use the long name property. It's always wise to identify components by long name to avoid ambiguity. Now, if editing the long name directly doesn't suit your needs, there are a couple of methods that give you the same ability to add, remove, and replace namespaces that you would ordinarily use through the UI. So we have process object namespace, which applies to a single component, and process namespace hierarchy, which operates in the same way, but applies to the component's branches as well. Finally, we come to properties. As we've already seen, properties are owned by the components they describe, and so every component has an instance of the FBProperty Manager class called PropertyList. If we want to get to a certain property for a component, we call the find method of its property list to ask for the property by name. Here we're getting the show property for our cube. Now this gives us the actual property object, in this case an FB property bool, that describes whether or not the cube is shown. We can get or set the value of any property by using its data attribute. Note the distinction between cube.propertylist.findShow and cube.show. Cube.show behaves pretty transparently, as if it were a raw Boolean variable. It's a convenient alias that keeps us from having to deal with property lists and objects directly. But under the hood, these two lines are functionally equivalent. I point this out because not all properties are aliased like this. It's preferable to use these aliased attributes when they're available. But if you're dealing with an obscure property and you can't find an attribute in the documentation or in the results of a call to dir, know that you can always go through the property list. So those are the key things that you can do with any component in your scene. We obviously can't go through the details of what each individual subclass of FB component does. But to round off our discussion of the class hierarchy, let's briefly talk about a couple of subclasses in particular. FB Box is an important class that implements real-time evaluation. Anything animated, and in fact most of the things you see in the Navigator, are boxes. A box has input animation nodes and output animation nodes, and it performs some calculation in between. FB Box implements a whole lot of exciting functionality, and it's the stuff that makes MotionBuilder MotionBuilder. But for the purposes of writing scripts in Python, it doesn't do much that we need to concern ourselves with now. For right now, just think of a box as an animatable component. Finally, we come to FB Model. Models are unique in that they have a spatial representation in the scene. Every model has a translation, rotation, and scaling value. And as we've seen before, we can edit these by assigning new FB Vector 3D values to them. As an aside, you can get and set a model's transformation matrix directly with the getMatrix and setMatrix methods. The last key thing to remember about models is that they're hierarchical. Every model has one parent model and any number of child models. To recurse through a model's branches, you'll typically iterate over its children list. To edit these relationships, you can set the parent property for a model. We'll uncover more details about working with models and other types of components in the next couple of videos. And now that we have an understanding of the components that make up the scene, in the next video we'll be able to talk about how to get access to those objects. Until then, thanks for watching.